What you're about to witness defies not just our expectations, but everything we thought we knew about the limits of flight control, stealth technology, and sixth-generation fighter development. In this latest video, captured during the 5th recorded flight test of China's mysterious J-36 stealth aircraft, something extraordinary unfolds. A single maneuver, barely a few seconds long, has sent tremors across aerospace communities, military intelligence circles, and global defense think tanks. The aircraft doesn't just perform a turn, it executes a sharp, physics-defying twist at low altitude with a fluidity and confidence that instantly raises a critical question. What exactly are we looking at? This isn't a conventional aircraft performing a textbook turn. This is a machine sculpted for air dominance, maneuvering as though the air itself is an extension of its will. In this moment, we aren't watching a test. We're watching the debut of a doctrine. From the very first frame, the footage strikes a chord. The J-36 glides into view low over the ground, maintaining altitude with a terrifying ease that only comes from immense engine power and advanced fly-by-wire algorithms. The airframe, tailless, angular, wide, is unlike anything currently fielded by China or any nation for that matter. There are no vertical stabilizers, no canards, nothing that breaks the smooth, sleek surface of its stealth-optimized silhouette. The aircraft looks more like a black dart, cut for speed, shaped for silence, and refined for evasion. Every line is razor straight. Every curve is precisely placed. This isn't a derivative of the J-20. It's not a regional airframe updated with stealth panels. This is something born in the shadows of a high-tech aerospace program. Something new. And then, without warning, it happens. The J-36, flying at what appears to be near transonic speed, suddenly begins a turn so tight, so violent, and yet so impeccably controlled that even analysts accustomed to fifth-generation capabilities are stunned. The turn occurs with no drift, no visible counter-thrust correction, no deviation from the axis of control. The jet banks hard, almost pivoting in midair, holding a near-perfect radius as it arcs across the sky. A trail of vapor briefly flashes off the wing roots, marking the onset of localized compression. The G-forces here must be staggering, and yet the aircraft glides through them like a machine with no weight, an extension of pure propulsion and algorithmic control. There's no shake, no jitter, just smooth, decisive motion. What you are seeing is not just agility, it is precision under pressure, executed at a level that borders on the surreal. But the key to understanding this maneuver lies not in the motion, but in the exhaust. Slow down the footage. Focus on the rear fuselage. Just beneath the edge of the aircraft's engine shroud, there's a detail that changes everything. 3 distinct exhaust plumes are visible, positioned in a triangular spread. Not 2, not a single wide nozzle. 3 separate engines. This configuration is almost unheard of in modern stealth fighters. It suggests something radical, a design philosophy not constrained by convention, but driven purely by performance optimization. A tri-engine layout offers immense benefits. A significantly enhanced thrust-to-weight ratio, greater redundancy, and more adaptive vector control capabilities. It also presents extreme engineering challenges, but based on the visual evidence, China may have already solved them. The thrust nozzles themselves are unlike anything we've seen on the J-20 or even Western counterparts like the F-22 or F-35. They appear subtly canted, possibly shielded, and may even feature advanced fluidic thrust vectoring, a form of directional airflow control that doesn't rely on physical surface deflection. In such a system, small internal bursts of air redirect the main exhaust flow, allowing for agile movement without compromising stealth. This means the J-36 could be achieving its insane turn radius without any external control surfaces moving at all. It's all done internally, silently, invisibly, and with stunning effectiveness. Such a system, if confirmed, would place the J-36 at the bleeding edge of aerodynamic and stealth integration, potentially years ahead of current Western fielded aircraft. And then there's the glow. The burn from the nozzles is intense but focused. It isn't the wild, chaotic plume of raw fuel burn. It's tight, controlled, and possibly shaped by electromagnetic fields or directed plasma shielding. There's even speculation that infrared suppression tech is at work here, narrowing the heat signature into a low observable cone that would make IRST-based targeting systems far less effective. This single detail, that the J-36 may be actively managing its heat signature during aggressive maneuvers, raises alarm bells, because that level of control isn't just stealth, it's invisible aggression, a predator whose power hides behind thermal silence. But the revelations don't stop with the engines. Recently, Chinese military expos and state-connected media outlets have begun showcasing scale models and digital renders of what appears to be the J-36, or its full-scale prototype. These models reveal a cockpit layout that is already generating serious debate in the aviation world, a side-by-side twin-seat configuration. This isn't just unconventional, it's revolutionary. Unlike tandem cockpits, which are used primarily for training or limited mission support, a side-by-side layout suggests a much broader set of roles and mission parameters. It changes the very DNA of how the aircraft functions in combat. The logic here is strategic. One pilot can focus exclusively on piloting, maintaining airframe orientation, threat avoidance, and tactical movement. The second pilot can manage the sensor fusion systems, operate AI-assisted targeting or electronic warfare modules, and coordinate unmanned drone assets in real time. In other words, the J-36 isn't just a fighter. It's a combat command node capable of integrating battlefield information, controlling swarms, and executing layered multi-domain operations, all from the cockpit. In a future where war is fought in microseconds and data overwhelms the human brain, this level of crew separation and collaboration could be decisive. Now think about the implications when paired with its internal volume. Judging by its wide fuselage and airframe depth, analysts believe the J-36 could house a significant internal weapons bay, perhaps one of the largest ever seen on a stealth aircraft. This means it could carry long-range air-to-air missiles, precision-guided munitions, loitering drones, or even hypersonic glide vehicles, all without sacrificing stealth. And thanks to its flying wing structure, there's room for modular payload configurations, allowing the aircraft to switch between air superiority, ground strike, jamming, or recon missions in a matter of hours. This isn't versatility, it's multi-role supremacy engineered into every rivet and beam. But raw design alone doesn't win wars. Capability must be tested, pushed, broken, rebuilt. And based on patterns from earlier Chinese fighter programs, we can predict what comes next. The J-36 will likely undergo a series of increasingly brutal flight trials, each designed to push a different subsystem to its absolute limit. Expect vertical climbs at full afterburner, stress testing the tri-engine configuration under asymmetric pressure. Watch for sustained high angle of attack flight, where the aircraft holds a near vertical posture, testing aerodynamic balance and adaptive control surfaces in near stall conditions. We will also see flat spins, forced intentionally to study recovery systems and determine whether fluidic vectoring can reorient the jet without aerodynamic lift. Every one of these maneuvers is a calculated risk, but China knows the world is watching. These flight tests are more than engineering milestones. They are strategic messages, broadcast in flame, motion, and silence. Each second of footage adds another layer of data, another breadcrumb for analysts, and another signal that the age of sixth-generation combat may no longer be theoretical. It may already be entering operational evaluation, and that should concern everyone. Because while the United States continues to field test concepts like NGAD behind closed doors, China is flying something real, something powerful, something the J-36 footage now proves is maneuverable, stealthy, and potentially combat-ready. It's no longer a question of whether China can build a sixth-generation fighter. The question now is, how far ahead are they willing to go? Every test flight, every prototype, every model leak, these are the pieces of a growing mosaic. And you can be sure that right now in think tanks from Washington to Tel Aviv, in hangars in Nevada, and bunkers in Tokyo, experts are poring over every frame, every pixel of engine glow, every angle of shadow on this new machine, because they know, as we know, that the skies are changing. So stay with us, because we'll be right here decoding every signal, tracking every breakthrough, and bringing you exclusive, frame-by-frame analysis of the most advanced war machines ever built. Like this video if you want more detailed breakdowns of future tech. Comment below with your theories. Is the J-36 already the world's first sixth-generation fighter in practical testing? Or is it still chasing the vapor trail of America's NGAD and Europe's FCAS?